So this time we have two speakers, Daniel Liszka, who is Senior Business Development Manager at VMware, working with the world's leading cloud providers, including Microsoft, Google, and Oracle. He was building Bitnami for many years before the acquisition by VMware. And Wojciech Kocjan, who is staff engineer and an architect at VMware. He has been working on packaging application for the last 10 years with focus on public, private, and hybrid cloud, as well as containers and Kubernetes. They will be talking about deploying cloud-native application in an environment which is both on-prem and cloud. Hopefully they will show us how to achieve that using VMware's Bitnami application catalog and NSX Cloud, which is VMware's hybrid networking solution. More than that, the session also shows how you can automate application updates with CICD built on the GitLab Certified by Bitnami VM. So please welcome Daniel and Wojciech on the stage.
Cool. Good morning, everyone. Still good morning. Before we begin, a quick question. How many of you use open source on a daily basis? And how many of you use open source in production? And the last question, how many of you use open source or this building blocks component in the middle layer? This is an example, like simplified overview of modern application nowadays. We all try to reuse code. We all try to use open source projects, products for databases, for logs, for caching. And it saves some time, but at the same time, it brings some kind of complexity. Because nowadays, all these numbers are only growing. And we have more code repositories at GitHub. We have more containers being added and published in Docker Hub. Not always we know how everything is actually built, but we actually use it for our production services. So complexity is one thing what I wanted to bring to your attention. Another thing is legal issues. Like, do we really understand each and every open source license we use in all these different libraries and components? And the last thing is security. Do we know who actually wrote this code? Do we have CICD pipelines to keep everything updated? Like, we all probably know about GDPR, and like the fee that you have to pay in case of data breach is only 4% of your revenue, annual revenue. It's minimum $20 million. Apart from that, we have all these different components, at least 20 for like generic applications that we're building nowadays. We have 3 different groups: developers, security team, and operations. All these different teams, they bring their own complexity, tools, processes, and pipelines to the whole picture. And for developers, it's important to have convenience, to have a choice that I want to use Ruby for this microservice, I want to use Scala for something else, I want to use Go for that particular piece of service. And for operations and for security, it's important that everything is auditable, that it's easy to manage, it's easy to upgrade. And in this presentation, we will also try to show you how to achieve that, how to connect these both worlds, developers and operations and security teams together. So actually 2 months ago, when we were working on this presentation, we said, okay, so let's try to create some kind of laboratory. And we have chosen a sample application that we are going to work on today. It's a modern application built with microservices. We have Golang, we have Python services, and JavaScript, Node.js. We also use MongoDB. And we use different environments as well. Just to make things a little bit more complex, we are going to deploy this application on Kubernetes. We will move some parts to the cloud, and we will keep CI/CD with GitLab on-prem. And we will try to connect all these different pieces together. So agenda for today is really simple. We'll talk about Bitnami first and our new role at VMware right now and how can we help you guys in this hybrid world. And then we'll show you a demo. So you know me, you know Wojciech, and we both were building Bitnami for the last 13 years. We started around 10 years ago when the team was around less than 10 people. And we were trying to help, at the time, open source companies like MySQL to streamline and to simplify deployment process across different platforms. At the time, we were building installation packages for them for macOS 10, Linux, HPX, and some other weird operating systems. And at some point, we realized that we are getting better and better in not only understanding open source components, but also automating the whole life cycle. And we said, okay, so let's try to build other open source projects and make them available to the community for free. And that was the time when Bitnami got created. And our mission from the very beginning was to, hey, let's take all this awesome open source software and make it available to everyone and everywhere. It is how it looks like today. So we have more than 180 different components. I like to call it building blocks because those are like different pieces that you can just select, connect together, and you have 80% of your new application done. You just need to build your business logic on top of that. And all these different components are available and continuously maintained across all these different cloud platforms. So we support AWS, we support Azure, Google, Oracle, IBM, name it. We have different formats from installers to virtual machines, cloud images, and apart from that, apart from single VM images, we also support multi-tier solutions. So we have CloudFormation templates, Terraform templates, Azure templates, and on Kubernetes side, Helm charts and containers as well. So we try to maintain all these applications from different categories, from e-commerce, e-learning, data processing, artificial intelligence, for everyone in all these different all these different environments. We have more than 1,000 releases every month. Of course, this number is changing because one day you have 3 updates, another day you have a security issues like Heartbleed, and you have to re-release and rebuild everything. And if you understand that, you know, all these different components across more than 20 different platforms and more than 1,000 releases every month, that you have to build from source, because we compile everything from source, and then we package everything. We add like some kind of customization layer, different for Azure and different for AWS and other format. And then we test everything as well. I think it would be a very interesting topic for another session. Actually, the Bitnami pipeline inside, before any release, will try to deploy a very specific package in the native environment. What does it mean? It means that, for instance, containers and the Helm charts are tested on top of AKS, EKS, PKS, IKS, all these different incarnations of Kubernetes. And actually, we try to create from scratch Kubernetes cluster, then we deploy everything, then we get inside and we try to understand how healthy is this workload at the moment. And apart from that, we have functional testing for each of these applications. So for instance, in case of Jenkins, we will actually try to connect to this application, connect to Jenkins, log in, create a new job. Is it working? Is it fine? That's a piece of news from May 2019. Bitnami has been acquired by VMware. And right now we are actually an important part of the build story. Project Pacific is a very interesting thing upcoming soon, so I really recommend you to read about that. So as I said, all these different open source components are maintained by Bitnami. Every one of you can just go and use it internally. If you go to Docker Hub, actually our containers are really up to date. Very often containers maintained not only by upstream projects, but also by other companies. Sometimes you have to pay for it, but it's not really up to date. Our stuff is really updated, and you have everything available on GitHub, how everything is built. You have full control and full auditability of every package. And why is it important? It's important because of the security issues. Nowadays, we do not SSH to different machines, virtual machines. We do not update stuff. We have CICD tools, and we have to quickly get the new artifacts to be able to keep our systems, our workloads healthy. And in case of Heartbleed or other security issues, we're actually able, with this automation, because everything on our side is automated, we are able to bring it to you like in less than 48 hours. Sometimes it depends on the cloud workload. At the very early days when we started working with different cloud vendors, I will not say which ones, like we were actually killing some of these clouds just because everything was done in parallel. So how is it done? That's like a very simplified overview of Bitnami Pipeline. We are actually tracking all open source projects from OpenSSL to Jenkins, GitLab, Python, Ruby, etc., etc. And for every change our system notice, we automatically recompile everything from scratch. Once it's recompiled, we rebuild. As I said, we test, and then we automatically publish everything to all these different marketplaces, and for instance, Docker Hub. Okay, so with this simple introduction, let's jump into the demo.
Hi everyone, thank you for that, Daniel. So what we're going to try to show today is how to solve this specific problem. So many of us have companies or are working for companies that have workloads running in multiple places. So this starts with public clouds at the top. Then we may have some sort of workloads in the data centers along with branch offices. And the problem is that we'll also be running VMs, containers, and how do we interconnect all of those items? We've shown Bitnami there because, as Daniel mentioned, we have solutions for every single of those use cases. But the problem is, once your workload is in multiple places, how do you make it secure and easy to use? So for that, we've extended the demo to also include VMware's NSX, which is a software-defined networking product that basically allows deploying NSX Cloud, NSX-T, and multiple incarnations of NSX in all of those environments, including things like Internet of Things and telecommunication infrastructures, and provides us with security, with basically a single networking layer that we can work on top of, and abstracts all of the connectivity issues. So for example, we could have, and we will have, a workload in a public cloud, which will be a MongoDB server, and then we will have our private data center running Kubernetes connecting to it and fetching data from that, as well as we'll have a VM in a private center connecting directly to the Kubernetes clusters to make a deployment inside it. So we'll have connectivity across the board, and this is one of the nice features of having VMware as integrated with Bitnami solutions, is that we can build all of that hybrid cloud environments and be able to deploy everything as it's in a single public cloud or on-prem. So Daniel touched base on what we're going to demo. This is a basic modern application that all of you are developing today, and that's basically a few tiers. So we have the front end that's served by Node.js. We have the user service that's responsible for logging in. We have the cart. We have the order service. We have the payment service and the product service. So this is basically a web application for ordering fitness-related items. VMware's cloud advocacy team has built it several months ago, and this is the location on GitHub where you can find the application. There is also an incarnation of that specifically done as this demo, which is called VMworld App 2019. And there is a really nice page, cloudjourney.io, that has a lot of interesting information about how multiple VMware solutions, and maybe not even only VMware solutions, can be used in your journey to the public cloud. So this application, what we've done is we've moved all of those components to be using Bitnami images. So initially they were mainly using upstream images. We've converted that to be using Bitnami images. We've added a CICD pipeline to show how any change would trigger a rebuild of the application. And we've also used an open source project called KubeApps, which part of which is shown on the right side, which basically allows us to later on deploy the application and manage the lifecycle of that application. So the idea is that this would provide us with a pipeline that will allow us to later on deploy and choose when an application will be deployed to staging or production or any other environment you may have. What we've also done is, and one interesting aspect of this, as Daniel mentioned, GitLab is going to be run on-prem in a vSphere environment, which is VMware's virtualization low-level environment. That's also using Bitnami images. That's also using Bitnami OVA that we've just imported into that data center. Now we're going to be also running MongoDB, which is going to be run in public cloud in Amazon. And we've just taken the Bitnami image out of bitnami.com website. We could also go to the marketplace. There's really no difference between those two. It's just that we've taken an out-of-the-box Bitnami image as well. And this is the idea. So we'll have a Kubernetes environment, which is Enterprise PKS, which is Pivotal Kubernetes Service. And we're going to have our application deployed there, as well as KubeApps. And KubeApps is an open source project that's a UI on top of application deployment mechanisms. Today it focuses on Helm, but it's also going to focus on different deployment mechanisms in the future. So this is where our application will be, and this is where we'll have the UI to manage that application's deployment. Then we have GitLab, which is deployed in vSphere. And then we have the public cloud, where we will have the MongoDB instance, and all of that is going to be interconnected by NSX, and we're going to show some of the connectivity pieces as well. So the goal of the demo is this. Developer changes some of the source code of the application and commits it to a Git repository. Then GitLab automatically will start a build and will use the pipeline that we've previously defined. Later on, that's exactly what I meant. So GitLab starts the build, and it uses the runner to build it and build all the Docker images and Helm charts and push it to the Docker repository and Helm chart registry. And then that chart becomes available in KubeApps, and at the end, the developer may just deploy it to wherever he or she wants. So this could be staging, or this could be production. I think at this point, we will just start with the actual demo. It's going to be, because we were worried how well the connectivity will be, we have recorded it. So
yeah, but that one I have to, it's too fast. Okay, so in this video, I'm going to show you how did we set up the whole environment. Like how did we deploy MongoDB and GitLab, just to show you that it's really easy. You know, like Bitnami actually does for you the hard part, and the only thing what you have to do is just to select the target and then deploy the application there. The second thing what I want to show you here is NSX, but like at the end, this is just our example. With Bitnami, you can actually deploy it anywhere and connect the way you want. It may be with Google, it may be with any other Kubernetes incarnation. And the third thing what I wanted to say here is we are not NSX experts. For us, it's also some kind of learning experience. It's amazing that like in a few days we were able to connect all these different pieces together. So we start with MongoDB, and at Bitnami webpage you can just get like different targets and platforms that we support. In this case, we select AWS, and we will directly deploy it in AWS console. So we select VPC and network already pre-created for us by NSX team and by operations. So we are developers, let's say, and when we want to deploy it, we set specific tags. Let's call it app fit MongoDB, and then the only thing what we need here is NSX.network, and we set it to default to be automatically detected by NSX infrastructure. And then the next thing is going to be about, like, once you have this virtual machine running, we will have to connect via SSH and install a special kind of agent. So you may detect the new virtual machine on NSX side, and that's it. Actually, you don't have to do this part if you have your own golden image, or if you have like your flavor operating system you want to use with an agent already pre-installed, then you can actually skip this step. So we have virtual machine running, we have IP address, we see that tags are already assigned, and we will switch to NSX Cloud. NSX Cloud is actually connecting cloud and on-prem just to have like consistent experience. So here we get to NSX-T, where you can actually find our MongoDB, and you can see that all tags that we have here are already assigned automatically. And tags are important, at least for us. We are really basic users here, just because you can do really great things later with that. So you can create groups, you can assign roles, and you can actually lead operations, as we said before, to define security policies and let developers just to work on applications and assign tags, and based on tags, very specific security measures are going to be applied. So then the second thing is GitLab. It was the easiest. We just downloaded the OVA from our web page. There are some other ways right now we are working on, like there is a VMware Cloud Marketplace where you can actually go and also deploy it automatically to VCD, to VMC on AWS, and the number of targets is going to grow with time. And then we have GitLab already running in vSphere. We have some tags that are assigned, and here in NSX you already see that we have our GitLab running. We assigned a tag called CI tier. Kubernetes pods are automatically detected, pre-integrated, so they are seen as logical ports, and all labels that you have in your Docker file are automatically detected here as well, so you can define some policies there as well. And then the final part, I'm not going to describe every little piece here, but the most important thing is to remember that you can actually see all these different workloads and machines that you have running across different targets. You automatically get tags assigned to all these different workloads, and then here we define a group for virtual machines and for Kubernetes pods, and we actually can see all these different services assigned to this group. So you can create a group for all services, you can create a group for CI only, you can create a group for database only. And then you can define rules like, for instance, my application services in this group can only connect to this group of database services. Or external network connectivity is only possible from application ABC. And this way, this tool can be actually used only by security and operations teams, letting developers just focus on their applications. And this is an example of, like, how can we add a rule? And I think in this case, I was adding the one for connecting to MongoDB service, which is running inside AWS, but it's not really important because you have some kind of overlay across all these different networks. Yeah, so as Wojciech said, I think that the most important part here is like consistency for me. At least that's a big win I get with NSX, that I can actually focus on something what's important for me, and it doesn't matter what kind of tool or what kind of open source project I use. I get this consistency and manageability with Bitnami, and I get operations and security with NSX.
So this is the second part that's about CI/CD, and let me just come here. So this one is slightly slower. Hopefully I don't need to pause it. So this is our application already imported into GitLab that's running on-prem. As I mentioned, it's available on GitHub, but we imported it for the CICD pipeline. We'll start off by showing that it is running the Bitnami images. We're just searching from Bitnami / and then we can see a lot of from Bitnami / nodes. There should also be Minidep, MongoDB, Redis, and yes, Minidep. We use Minidep because for Golang applications, we just need the operating system because the Golang binary is self-contained. So right now, this is just applying the change. So we went to VS Code, and then we're going to just create a branch. So this is, and then make a change. So the change is really simple. We're going to change a text in the front end of the page, changing the text free returns for 3 months into free returns into 6 months. And then basically, we also increase the version of the chart so that the update is visible in the UI, in the KubeApps UI. So we've only changed those 2 files. It's two lines of change, and then we commit everything and push it to GitLab. We're going to see that we have multiple GitLabs in this demo environment, as Daniel mentioned. We're just using PKS, and we're just using a GitLab related to that PKS environment. Well, we also have a demo in EKS, and we have demos in other places. And basically, this flow is the same across different clouds and across different solutions. So now that we've committed it and it has been pushed, we will see that in GitLab, we're going to see the change. We can go in and see that the build has already started. It says it's running, the one at the top is running. We can go in and inspect, for example, the change and see that this is what we've committed. One important thing is, I think it's not really visible on the screen, is the identifier of the commit, because that's how the builds are going to be, the Docker image builds are going to be tagged later on. So we can see that the tag is the same, but as I said, it may not be large enough to see in the screen.
Can you explain what we do in the pipeline?
Yes, sure. So right now I'm just showing the change as well, so we can see this is exactly what we've just changed, and we're going to go back to the pipeline right now, I think. So the pipeline contains of 14 steps. So we have the initialization here. Then we build all of the Docker images. We push all of the Docker images. And at the end, we build and push the Helm chart. So the Docker images are separate images for every single tier of the application. The Helm chart is a definition of how to deploy that glues everything together. We've modified the Helm chart not to deploy one of the MongoDB instances, but rather than that, expose the MongoDB connectivity details as a parameter. This is KubeApps. So this is an open source project from Bitnami that we've deployed inside of the cluster. And this is a catalog of applications that are available to us. This is the Acme Fitness application. We can see It was built some time ago, so the date was not really today, but we could see that there was a new version that was just built with the version that we've mentioned. This is the image tag, so this is the SHA of the commit. The only thing we're going to change is we're going to expose it using load balancer, and then we're going to pass the connectivity details to the MongoDB database, and now we're going to deploy it with kubeapps. So that was a Helm chart, which has inputs as a YAML file, and then we've just modified that YAML file to change the inputs. What I'm showing right now is an older version of the application that we have deployed. So kubeapps shows that there is a new version available of this application. It also gives us the detail how to log into the application and connect to it. And we've just opened it, but we will show in a bit that there is a different text in each version of the application. So right now we can see that kubeapps also shows everything that was deployed. So we see all of the Kubernetes resources, as well as all of the values that we've passed. And now we can go and connect to the new version of the application. Hopefully that's what's going to happen now. And I think I will start by showing the difference in the text. So this page is going to say that we have 3 returns in 6 months, while the previous one is going to say that it was for 3 months, but I think we're just waiting for it to download, all of the images to download. All right, so we're also going to show the database connectivity. So right now I'm connecting to the database, and we're showing that this is the latest order that was ordered. So we basically took a collection of orders and then retrieved the latest one. What we're going to do now is we're actually going to show that this application works by trying to order a bike, I think. Yes. So we're going to try to order a bike, and obviously this is a fake website, so like the delivery method is kind of silly because I believe it's by a tractor, but we'll get to that later. So we're just going to enter some test data. There is no validation of the data whatsoever. We're just going to copy the address from the bottom, which is obviously fake as well. And then all of the details and some random phone number, as well as an email address. Again, this application is available on GitHub, so if anybody really wants to deploy it and have fun with it, go ahead, it's there. So again, the delivery was going to be made by a tractor. And then some random credit card number just to demo that it works, and some dates. We do have a validation for the expiration date. That's the only validation in place, so I had to change that. And now we can see that we have some identifiers of the order and everything else. I run the same query against the database, and you can see this is the exact data that was entered. And yes, and that's it.
Slide.
Okay. So let's just quickly go back to the.
I mean, the good thing about this application is that the pipeline we use in GitHub is in GitLab is actually available in our GitHub account as well.
Yes.
So you can easily recreate this environment with almost any other platform.
Mm-hmm. And I think that's it. So I think we can take questions now, and then we have one slide at the end just to remind you of.
Yes, thank you guys. We have one question in Slido.
Okay.
So in a typical Bitnami image, you usually discover that installed components are started and configured in a pure Bitnami way. Why so hard? So could you elaborate? I guess it's basically secure by default, but maybe you have another view of that.
I can take this one. So the answer is, I guess first part of the question is, why are we using Bitnami fashion of starting services and Bitnami fashion of delivering the services? We've made a decision some time ago, and maybe I'll just switch to that slide, because so we run into a lot of issues by trying to use system packages for some of the things. We use system packages for a lot of things like system libraries like SSL and a lot of other things, but we've discovered that there is no consistency between specific Linux distributions on versions of some of the packages. Like the version of MySQL will be completely different across every single distribution. So our answer to that is to ship our own version of MySQL and then have a set of applications and versions and building blocks that we've verified to work together. So our answer is for the components that we think people care about, which is I want that version of MySQL and I want that version of PHP because this is the version of PHP that say Moodle requires. then it makes a lot of sense for us to be choosing that. And if we want to be choosing that and managing the versions of those applications, they have to be bundled by us. In that case, we cannot really use the system packages. And in that case, again, it makes more sense for us to be also managing the life cycle of starting and stopping of the applications. So I guess this is the answer why we do this.
Let me add a little bit color to that part as well. Like with Bitnami, for instance, installers nowadays, like the Linux one, you can actually install it on any Linux distribution and it will work. And that's only because we bundle all these different dependencies inside. It makes our installer a little bit bigger, but at least it proves that if you click 5 times, you will have your WordPress, your Jenkins, or your GitLab up and running quickly. And I understand that from time to time we get these questions, why do you have this weird Bitnami way? It's for us some kind of consistent, right? So if you understand once how GitLab is configured and how it started, any other service or any other application from the 180 is going to be configured the same way. We are changing. I mean, I would like to say that we hear you, we hear this feedback, because for instance, our containers and Helm charts are getting improved. So instead of using our Bitnami tools, and these Bitnami tools were good, I really like them, but they were hiding some kind of logic inside. We are changing and we're trying to build, for instance, bash scripts based on our metadata, because bash scripts, maybe it's not the perfect way of defining and running services, but at least it's something what you can actually read and you know exactly what's going on inside.
Yeah, and I just to add to that, I think one of the that's one of the questions I get a lot, which is why would I use Bitnami, especially container images, instead of upstream? I had that question just a few days ago. My answer to that always is what Daniel mentioned. So it's always maintained, it's always up to date. We always have them secure by default. It's certified, which means we've tested them, which means we know that they work, that if you take a MySQL image, it was also tested to be working properly as part of a MySQL cluster. If you take Jenkins or Slaves, it will work with that Jenkins image as well. It's free, which means that you don't need a license even if you want to use it for commercial purposes. We have some offerings related to commercial solutions, but we're not here to talk about them today. But my point always is, like, they're always up to date, they're always configured to work properly, and there's also consistency. So if you take 30 container images, and if you take Tomcat that has username Tomcat, then you take MySQL that has username Daemon, and they all store data in different places, it's kind of more difficult to build things on top of them if you have a lot of components. With Bitnami, everything is on GitHub, the naming is consistent, the tagging of the images is consistent. So if you read the documentation once, you know how all of our images work. So it's kind of, if you buy into the ecosystem, it's much easier. It's just the learning curve is slightly steeper, but as Daniel mentioned, we're trying to improve it.
Cool. We have a couple of minutes, so any more questions from the audience? Do we have more questions? Okay, so maybe following your answer, so how does the contribution model looks like? If I would like to contribute to your packages, I would like to extend, improve something. How does it work?
In case of GitHub containers, I mean, in case of Bitnami containers and Helm charts, and also some Terraform templates, we actually at some point started moving everything to GitHub, so you can fork it, you can create a pull request. So we're actually open about that. We get very often translation requests as well, but like this is done via email. We don't have any system available publicly. Anything else? Like documentation is also available.
I think there's one additional thing worth mentioning. So some of the things we put on GitHub are rendered automatically, like Daniel mentioned about the shell scripts. So if you make a PR against some of those scripts, we may need to go in and add it internally. True. So the outcome of that PR may not be one by one exactly what you've submitted, but we're definitely open to contributions. We're definitely willing to take them in, and even a request to add functionality, we always look into that. But if someone provides us with a PR, that's more than welcome, and we try to accept all of them.
Yeah, and for instance, all Helm charts from Bitnami, we are actually core contributor to Helm. So we do not keep it separate. We keep it as part of Helm project. And you can find all our Helm charts, part of them, in our own repositories, but we're trying to push each of them to the core. So we don't own it, but we just contribute there.
Thank you. That's awesome. So that will be all. Please give warm applause for Daniel and Wojciech.
Thanks, guys.